All right, folks, we're going to get started now. We're up to 22. Wow, it's a very high percentage of the people. It's great. People who registered definitely like this topic. Glad you could join us. And again, Shira, thank you for joining us at such a late hour for you. I'm going to go ahead and turn this over to you, and you can introduce yourself a little bit more and take it away.
Great. Thank you so much. Thank you for having me here today. Super excited to be a part of this great meetup group. And hello, everyone. I'm Shira, the CEO of Solvo. And I think that what we're going to talk about today is relevant for the developers and the DevOps engineers who are with us today. Very often when I come to organizations, I see that the DevOps engineers and the SREs are a very important persona in the R&D organization. And even though not all of them write code, they work closely with the developers, and they always give a second eye to what is going to be deployed. So I think that this is a great chance for us to talk a little bit about what we expect from developers when they deliver software and how we can help them to do it better. Now, a couple words about myself. As I said, I'm Shira, and as Dave was kind enough to mention, I do a lot of volunteering around security education in different forums. I think that it is our responsibility as a part of the community to share our knowledge and to help people deliver better software and better products. So I encourage all of you, if you have the time, please do the same. And let's get started. Also, if there are any questions along the way, please feel free to put them on the chat. I will relate to them as soon as we can during the talk. So let's start by talking a little bit about why are developers important in this process. You all know we live in a very software-driven world, and today we don't only deliver code. We also the code that we write is also the tools that accompany us along the way. It's the CI/CD chain that is very much codified. So it's the product and the tools that support around us. At the end of the day, the end user doesn't really care about the code. They are more focused on the product and make sure that the product is working. But for us, the people who look behind the scenes, we know that everything is based on the code, and the standards that we put will decide if we're going to deliver a product that is secured, that the users can trust, that is respectful of their privacy, that doesn't violate any of those regulations and so on. And the sooner we start setting those standards, the less problems we're going to have along the way. Now, from my experience, I didn't do a lot of software development work, but the developers as an audience are not really the type of audience that likes to be talked from above. Nobody really likes to be talked from above, but talking to developers and explaining them what they're doing wrong or how they should work differently is not always being accepted in a good way. And I think it's time we start talking to developers and explaining to them about how to get things done right in a different way. I'm talking about security, but I also think it's very much relevant to everything that has to do with the ops of our application. Because think about it, today, every software developer has their own AWS account or Azure account and so on. And they make a lot of decisions that has to do with ops or with infrastructure, even though it's not really their main expertise. So it's really our responsibility to help them do it in a better way. So what makes a good R&D organization or a good R&D culture? Well, there are several things that can help us do it better. And we need to make sure that our culture fits our vision and the place we want our organization to be at. We probably want to make it a very healthy organization that allows people to ask questions and feel very comfortable about it. It should be a safe place for everyone to ask that. And very often I see places where the developers don't feel comfortable to ask questions or to feel like they're doing it wrong. So it should be a place where people can feel comfortable not to know something and to know that their colleagues are going to be there to answer their questions. We also want them to fail and to fail fast, because this is how you learn. I prefer people to try something out and fail instead of not trying at all, especially not trying to solve problems is a problem for our organization. So we should allow them to try out those things. The team is so important. There isn't a product that was delivered by a single person. There is always a team behind it. And the team should know that if one of the team members fails, they should all be there to support them. And the last thing that never stops is our self-awareness and our continuous learning. We always have to focus on learning about new technologies. Who knew what Kubernetes was a few years back? Today it's super popular. So we never stop learning about new technologies, and we should continue doing so. And more than anything, security is a cultural issue. So that relates to the culture in our R&D organization. I feel like people in the R&D organization don't ask themselves often enough, what are the implications of what I'm doing right now in the security perspective? And I talk to developers a lot. And whenever I see I see them delivering a new component or deploying a new piece of code, I ask them, hey, how did you check that this is not vulnerable to something? Usually the answer is, I don't know, I didn't do that. It's not something that comes in mind, and it's very unfortunate. I'm not saying that everyone should know all the vulnerabilities, the OWASP top 10, every new CVE and so on, but this is something that when we write software, we should think about. It should come to our awareness. And I think that this is one of the key takeaways from this talk today, bringing those topics to our awareness. And when we talk about developers, there are several very basic things that don't happen enough. And I wanted to point them out here. There are plenty of more, of course, but these are very common mistakes that I see all the time. When I look at the user's code, at the developer's code, I see lots of accidents that happen because of weird naming conventions, weird mistakes. I see that the same variables are named differently. People use lower cases or upper cases, and they type it from memory, and then their code is not working because they didn't use the same convention as the rest of the organization, because there wasn't a good convention. Or when they name the different variables like tier 0, T1, T2, and so on. And what I think about when I see this is that whoever wrote that code didn't really think about the day when someone else is going to read that code and not understand what exactly did you mean when you wrote it this way. I have no idea what are you referring to, or how can I use that later. This also relates to the comments. People don't write enough comments and don't document well their code and their application. And this is a very, very basic thing to do. Testing. I know that all of you write some tests, but not all of you write enough tests. And test coverage is very, very important, especially in the CI/CD world, when you just commit and expect your code to make it to production within, a few minutes. If you don't write good test coverage, then your code might make it to production, and only there you're going to find some major issues. Testing is also a great place to automate some security testing. I will talk about that a little bit later. and the last thing, which is very, very, very basic, but for some reason I still see people make that mistake, is hard coding secrets and credentials. They hard code keys, they hard code passwords. And as you probably know, there are plenty of crawlers out there on GitHub. Just look for those. Usually if you by accident hard code an AWS account and credentials, it's a matter of minutes before you will be locked out of that account, and a crypto mining farm will arise over there. So that's also something everyone should just stop doing. I'm not sure why that mistake keeps on repeating. And these mistakes, skipped one slide. These mistakes, the mistakes that we find in the code can cause different kinds or can enable different kinds of attack vectors. As you can see, the common word here, and I just gave here a few examples, but the common word here is injection. And that means that on the user side, we can exploit some of the things that you did and either retrieve data or somehow read data that you never intended for anyone to see or to hear. And doing good handling with code and edge cases will definitely prevent a lot of these attack vectors. But this is also something we should always think about when we write the code. We should always try and think, what is the bad thing someone can do while getting this piece of data, this piece of information? And when we don't have this in mind, this is exactly when these kind of attack vectors happen. Today, if you look on Google, you'll be able to find plenty of servers that are vulnerable to SQL injection. And it has been on OWASP top 10 forever. But for some reason, it still happens. So sometimes we make fun of people that this happens to them, but this can totally be prevented by paying more attention and bringing it up to our awareness. Now, we still see those mistakes today because of two main reasons. One is time or the lack of time. As R&D organizations, we're always in a hurry to deliver the next feature or to close the ticket, or we are in the middle of the sprint. And whenever we have to stop and think about security, we usually don't put enough time for that. We leave it for the next sprint. We leave it for later. We think that someone from the security team will probably do the audit or the code review for us and fix whatever needs to be fixed. But it doesn't happen. Think about how many developers you have in your organization and how many security engineers you have in your organization. You just don't have enough security people to go over what you did and make sure that it's very stable and not vulnerable. The other problem is expertise. Most of you didn't learn about security and secure coding in university. And when you started your first job, you probably didn't learn a lot about security and secure coding. Your buddy or your mentor probably also didn't emphasize that, but put a lot more focus on your coding skills. And this is how we build the culture. So this is where we first started failing with implementing security. We didn't teach other people how to do it, and now we all of a sudden expect them to deliver secured products. So that's unfair. Code review is probably the single most effective technique to identify security bugs along the software lifecycle. Of course, we have plenty of good products to do that for us, but the code review is going to enable us to teach people how to write better code and also to detect different issues. It enables us to make sure that the code is readable and maintainable. It also enables us to learn about other components that we have in the software. Of course, we're usually more focused on the code that we wrote, but if we do code review, it enables us to learn about other components and also think about good ways to integrate them together. It helps us to improve our product, to prevent some accidents, to track and learn about how our product is evolving, and of course to share our knowledge. We need some security background when we want to do a security that has a code review that has to do with security. But I will try to give you today a few important tips and the checklist that you can follow. And even if you implement 10% of it, it will be better than what you have today. And also, don't forget that customers don't know if you did a code review that looks at security or not. This is something that we have responsibility for towards our customers, and not doing it might hurt our organizations and our employers in the future, because those security accidents are very embarrassing and can destroy businesses. I think that some people think that if they have a firewall, then it's probably fine. That's just not understanding how software works and how it's exploitable. So one interesting thing I want to share with you comes from the OWASP code review guide. This image is taken from there. You also have the link here, and you will have the slides later. It shows that, as you can see, manual pen testing and manual code review are, in most cases, better than the automated tools that are out there today. The list on the x-axis is different OWASP vectors, and you can see that the manual code review is most of the time is better than the other products. So it is, unfortunately, we still haven't found a good automated way to do it. And we always do code review anyway before we commit the code. So I suggest we take it as an opportunity to always have a look at security issues, at potential security failures. There are lots of things that we can look for when we do the security code review. I will not talk about all of them, but I will definitely give you a few tips or topics that I think you should pay attention to. In the same document that I mentioned before, coming from OWASP, you have a very long checklist that I highly recommend you take a look at. And again, pick a few things you can, from now on, implement in your code review. But I would like to mention what I pay attention to when I look at code. The first thing I ask myself is, do I need to store all of this user data? The more data you store, you obviously expose yourself to more risks. So always keep only the minimal data that you need, and try not to do it with the personal data, do it with aggregated data if possible. if you did keep some of it, did you send it in a secured way? Did you encrypt it? It can be the data that the user put in, but it can also be some metadata like IP addresses, cookies, and so on. So these should all be encrypted and sent safely and securely. Did we place authentication or authorization? And how did we terminate the session if those fail for some reason? Sometimes we forget about that little part of terminating a session. It's not always necessary to terminate the session, but we definitely have to make sure we handle it the right way and not allow a user to exploit the session and the session cookie. Have we patched or updated libraries, tools, and plugins that we usually use? We forget that this code that is available for us on the internet might also be vulnerable, and it's really good that the open source community tries to help us close those loops down. And how do we handle errors and exceptions? This is also very important. Not every error is an exception. For example, one example for exception can be not having an else in an if loop. For example, we should also put an error message for the customer, for the end user, but we should make sure that in the error message, we don't expose user data, or we don't expose another piece of data that might be exploited by an attacker. And this is also why we need to have proper logging for our application so that we can investigate what happened, even if we don't have a very detailed error message. Now, for a DevOps audience, this was a few slides about code review, but now I would like to move over to cloud infrastructure, which you might find more relevant to your day-to-day work. As I mentioned before, developers want to move fast in the cloud, and they don't always put enough attention into cloud infrastructure. And it is our responsibility from the DevOps standpoint to make sure that our infrastructure is secured and enables us the resilience and the security of our application. Now, I found that many people don't fully understand the IAM model. IAM is what the cloud vendors, is the mechanism that the cloud vendors gave us in order to do security in a very granular manner. If in the on-prem world in the past, we used to do security in the network layer, we had the firewall, we filtered by different ports and protocols, and didn't care about what is going on inside the data center because it was separated from the internet. Now that boundary doesn't really exist. I don't know where my servers are. So we were given this great mechanism to make sure that we know who is communicating with who or with what cloud asset. And this has a very, very simple structure. As you can see, we see here action, effect, and resource. The action is the API call that we can execute. The effect can be either allow or deny. Usually in AWS, for example, all actions are denied by default unless we allow them. And resource is a specific path to an AWS resource. This is the structure of the IAM file, the JSON file. And of course, we can create as many of these as we want and as many as we need. And I remind you that not all users know how to use this mechanism. So this is why very often I can see things like this. Effect allow, action asterisk, resource asterisk. This basically means that we are allowing all the actions on all the resources. This is admin permissions, basically. Don't use it. I mean, ever. There isn't really a good reason to use this kind of permission. There are plenty of other ways to restrict access. Once we gave this, it's really hard to go back. It's really hard to reduce those privileges, because we were always a little scared that we missed something and that any change to the security policy would cause some kind of internal denial of service. So we should really aspire to give a least privileged security policy to begin with. And it's going to look something like this. This is an example for what a least privileged security policy should look like. We specify the actions that we want to allow. In this example, I have a DynamoDB that I am allowing a get item action, and to also specify the resource we want to get access to. If we don't specify those specifically, it means that other actions can be executed on other resources. There is a very well-known incident that happened last year because a developer didn't specify an action and a resource. It happened to a very large financial institute in the US where a developer just gave access to S3 asterisks when they needed access from a web server to an S3 bucket. But this allowed access to all the S3 buckets in the account, also to the sensitive ones. This is why it's so important to specify the action and the resource. Now, people either go and write those security policies themselves, or they go ahead and use an AWS Managed Policy. An AWS Managed Policy is going to look, for example, like this. This is a DynamoDB read-only access. It's a screenshot, so you can't see, but it's pretty long. When you talk about a read-only access, you expect to see the name of the service and the API call of or read or get, but not a very long list of services that is not relevant to DynamoDB. I did some digging into this policy. I just wanted to understand better what did AWS actually give here. This is, as I said, this is a managed policy. So a lot of people feel comfortable to use a managed policy because they assume that AWS feels responsible for the actions that they allow to take here. But they are not responsible for it. It is you who is responsible. And in this case, there are several actions we can take here that are, it's not that they're not relevant, it's that they are risky for our account. For example, they allow us to make a get function configuration action. That means that we know it gives us all the function names, the ARNs, the aliases of those functions. It allows us to list all the lambdas in the account. We can do describe for security groups, which is really good for reconnaissance. An attacker can really use that to know about the security configuration in the account. We can describe subnets. We can describe keys. It means that we can get a lot of information about the keys that we use in this account. One of the most sensitive actions that this allows us is to list all the roles in this account. It means that we can get all the roles that we have, the specific path that they use, and so on. So using an AWS Managed Policy doesn't mean that we're doing it securely. When I talk to users and ask them how do they choose to do it, some of them tell me that they reuse the roles. For example, one person I talked to told me that he uses the same role for all the Lambda functions in his application. Now, I know that not all the Lambdas need the same access, but he doesn't have the time to stop and design what kind of security permissions his lambdas need. So it is our responsibility to find a way to give the least privileges in our application to prevent exploiting of them. So here are a few takeaways I would like you to take. Be a developer or a DevOps engineer. There are several things you can do in your day-to-day life that will improve the security of your application. I started by talking about the culture, and having security as a part of your culture is very important. You can start by asking yourself the right questions. Is what I'm doing now exploitable, and how am I risking the data, or how can I prevent exploiting of this data? God is in the details of the code. So the error handling, the logging, and so on are the small things that can help us do things better and investigate and research them and improve them. Code review is our chance to implement and improve the security culture. And as we talked about it before, developers don't really like to be told or to be looked at from above and to be explained about how to do things. So we should make things very, very simple and as automated as possible. Um, and if developers don't like to do security, we have to find a way to do it automatically for them, to do the more annoying tasks automatically for them, so that we can free up their time and let them work on whatever they like to work on. I added here a list of open source tools or free tools that I highly recommend using in different parts of our CI/CD process. So starting from the pre-commit with Talisman and ending with two tools that were created by Netflix. You will have this list, so you can have a look at it later. All of these are free tools, and you can think about if they can help you and they can help your organization to deliver better security. I also wanted to share with you a free tool that Solvo is releasing, and you can actually get early access for it. But we're releasing a new tool that does a health check for your AWS account and give you a security score, so that you can tell if you're in a rather a good position or not, and also give you a detailed overview of your IAM status, so you can see if you use those asterisks and gave very loose security permissions, or if your organization and your application are actually in a pretty good place. We also help you resolve those issues automatically. I have a serious problem with tools that only tell you what you're doing wrong without helping you resolve that. So by using this report, you can then get access to Solvo's free tool, and we will help you resolve those IAM issues and excessive permissions by improving your IAM. We can significantly reduce the amount of actions and access to AWS services that your application is giving. And as I mentioned before, I believe that security tools or ops tools should be very, very simple and straightforward to use. And you should see the value out of them very easily, very clearly. This was our vision when we developed this tool. So you can give it a try and see if it's working for you and if it's helping you to improve your application. And at this, I'm going to say goodbye to you today, but I will be answering questions if anyone has any.
Great. Thank you very much, Shira. Really enjoyed your presentation, and also thanks again for being up so late. Right? I don't know if I said it earlier, but yeah, you're up pretty darn late in your part of the world.
Yes, this is true.
So I've got one question for you, which is around the types of applications. Does it change the way you view security or analyze the access that your code has? If it's, I don't know, like an app with a user interface or a backend app or a um, maybe a mobile first app or anything like that? Do you find any changes or differences?
I think that very often it is believed that the exploitable part is the user interface. And it's true. I mean, it is very exploitable. Sometimes we can inject variables into the URL. So it is very much exploitable. But today, when you have search engines like Shodan, we can easily find the backend server as well. We can easily find an open S3 bucket, even if it didn't have even if it wasn't connected to a front end. So we can also easily make it to the backend servers, and we can easily exploit those as well. So the security configuration that we grant our infrastructure is very powerful, even if an application without a UI.
Got it. Okay. And is there a particular type of application that you feel your security check does best on, or does it really matter?
I don't think it's relevant to a specific type of application. It can be, a Java written application or a Python written application. It can be a mobile application, or it can be a web application. This is true to all of them. All of them are unfortunately very exploitable.
Okay, got it. We have a question. Well, it's just a simple question from Leon. He wants to know if he can get your slides for review later.
Absolutely. I will send them to you, and you can upload them to.
Yeah, I can post it to the meetup page or send a link to them in the follow-up.
Okay.
Okay. Well, I know it's so late for you, so I don't want to keep you too much longer, but I want to thank you again. We had probably the highest turnout in percentage of people registered that we've ever had, which is interesting. So, definitely the people who are finding this relevant are definitely finding it relevant. So thank you again. And it also reminds me that we should probably have another DevSecOps related talk at some point in the future. So great. All right. Well, thank you very much.
Thank you, everyone.